you. In unit 3, we are going to discuss about 8051 microcontroller. In unit 3, we are going to discuss about the 8051 microcontroller. See, they here architecture. The question is 1A. Draw the internal architecture of 805 microcontroller and explain the function of each block present in it. Okay. So, here we have see, the main unit in this architecture is ALU. ALU is the main unit here. ALU. Okay, this is here ALU. ALU. Arithmetic logic unit. Okay. So the input for ALU will be 2 number. As you know that it is going to perform arithmetic and logical operation. So here temp 2 and temp 1. These two are 8-bit registers, 8-bit storage registers. But these we are not going to use. The user cannot be accessible. So the two data is required to perform any arithmetic or logical operations. One should be most of the data. One of the operands should be an accumulator. One of the operands should be an accumulator register A. The other may be register B, or it may be some other register, or it may be memory location. Okay. So this value will perform the arithmetic and logical operations. Arithmetic and logical operations. So after performing arithmetic logical operations, the result will be stored in register. Okay. So this is about the ALU. Then this accumulator ACC is nothing but accumulator register A. Then register B is there. Register B. So register B is there. This is one of the register. Where it is having some special function also. Then this is about register and ALU. Then we have this RAM memory random access for storing the temporary data. It is of 128 byte. Then this is a RAM address to access the data from a RAM memory. We need address. Here the RAM address register is going to store the address of this memory location. Then we have ROM. It is also called the program memory. It is also called the program memory to store the program, or also called the code memory to store the program or code. Okay. So this ROM address will be stored in program address register here. Okay. Then there is a buffer. Buffer is just storage. So then we have one stack pointer. Stack pointer is there. This is used to hold the address of the data that is stored at stack. Stack is usually the part of RAM. Part of RAM memory location is used as a stack. Part of the RAM memory location is used as a stack. It is a part of the RAM memory location, not ROM. It is a part of RAM memory location. See here. And coming to the PSW, program status word, it is a PSW is nothing but the program status word. Program status word. Program status word. Status word. Program status word. It is called PSW. So it is having a flag bits, a carry, parity, sign flag. This will be there. That is in PSW. I'll show you in detail about this. One of the questions we are asked about flag register. this after performing arithmetical logical operation, depend upon the result. The flag bits are going to change. Then coming to the timing and control unit. Here, before that, there is one instruction register. Whenever instruction is brought from memory, into here processor, first it will be stored in the instruction register, then to send to the decode and timing control unit. Okay. So this timing and control unit will generate the corresponding control signal depend upon the instruction. Okay. For this, there is an oscillator is there. If you look at here, this is an oscillator. Oscillator is used to generate the clock. So all the operations will be synchronized with the clock. Clock is nothing but like this. Okay, this is the clock. Train of pulses with equal interval. Okay, this is called the clock. So here this timing and control are going to generate the control signal, program, store, enable. This is for ROM memory. To externally connect ROM memory, this control signal will be connected to the ROM memory. ALE address latch enable. To separate address and data bus, we are going to use ALE. Like say we are used in 8085 microprocessor. Similarly, here also we can use ALE, same function. And coming to the external access, any external memory to be accessed, we have to use this signal. Then reset for this processor. Okay. Now we have here buffer is a storage. Buffer is a storage here. Then PC increment. PC is nothing but program counter. Program counter is called the PC. Here you return program counter. Increment it is. To increment is one function is there that is going to hardware. It's automatically going to perform increment function. Then this program counter, as you know that I discussed about the purpose of program counter, it is going to hold the address of the instruction that is stored in the ROM memory location. That is the function of program counter. Then coming to the DPTR, data pointer register, is called the data pointer register. DPTR is nothing but a data pointer register. DPTR, data pointer register. Oh, same. It's a data pointer register. Okay, data pointer register. DPTR. It is used to hold the address of the data. The data here in RAM memory, as you know that in the 128 bytes, okay, single, one register is sufficient to hold the address, that is 8-bit register. But if it is data is stored in the 64, more than 128 bytes, it is externally if you connect the RAM memory, then we need to access the data from that memory. That address will be more than 8-bit. Then here the 16-bit register, we are going to import the address of the data that is stored at the RAM memory location. So this DPTR consists of DPH and DPM. DPH and DPM. Two registers, combination of two registers. So you can load separately 8-bit register and you can access as a 16-bit register. If you want to use as a 16-bit, means you have to use DPTR. If you want to use the 8-bit register, you can use DPL and DPH. So then we have ports, port 1, port 2, port 3, port 4. 4 ports are there. Port 0, driver, port 2. Each ports have latch and driver. Latch for storage, driver for to drive the external circuit. So each port is having 8 bits. P, for example, if you take port 0, P0.02, P0.7. Similarly, port 2, P2.0 to P2.7, 8 lines. Similarly, port 1, P1.0 to P1.7. Port 3, port 3.0 to port 3.7. Okay. So I think this is VCC and ground for supply for the controller. So everything I explained you about the architecture. Now we will go for the next. Question answer. These are, as I said, this register, this A, B, R0 to R7, this I will explain you separately. Data pointer DPH and DPL is a data pointer program from the PC. The importance of IO port. This is one of the question is describe the importance of IO port. Yes, IO ports are very important.